Graph analysis number 3 is a no calculator question in which the mean score was 2.74. And in this question, we are given g of x defined as an integral of f, and over here we're given the graph of f. Part A is asking if g has a relative min, max, or neither at x equals 10. And I know that g is going to have a minimum if g prime goes negative to positive, and g has a max if g prime goes positive to negative. The first thing I need to do in this problem is say what g prime is, and that just requires me to do the derivative of this integral. It's fundamental theorem part 2. The derivative of g is g prime. The derivative of the integral from 2 to x of f of t is f of x. Recall derivatives and integrals are inverse operations, so they cancel each other out, and I simply take my upper limit and I plug it in. And what this tells me is, even though this is labeled as a graph of f over here, it really is the graph of g prime as well. This connection needs to be made at least one time on your paper. It could be anywhere. You could say it in part A, you could say it next to the graph, you could say it up in the stem of the problem, you can say it in parts B, C, or D. It just needs to be said once somewhere, and that's going to earn you 1 point. And if this is the graph of g prime, I can see here at x equals 10, I do not undergo a sign change in g prime. That tells me that we have neither a max or a min because g prime does not change signs. Once you've said that g prime and f are one and the same, you can use them interchangeably. So even though I mentioned g prime in my explanation, it would be okay if you called it f. Part B is asking if g has a point of inflection at x equals 4. Because this question is asking about g, I'm going to use a gun chart with g prime, and g double prime is my guide on this one. A point of inflection happens in between these two columns right here. I could see it's when g prime goes from an increase to a decrease, or it could go the other way around, decrease to increase. I see at x equals 4, g prime indeed does go from an increase to a decrease. Therefore, yes, I do have a point of inflection. And my reason is because f equals g prime goes increase to decrease. You could also see because f has a relative max at x equals 4. So either of these two explanations is okay. And like I said earlier, you don't have to refer to f and g prime both. You could use one or the other as long as that connection has been made prior to using it in the problem. There are a couple of key words in part C that tell me what to do. One of those words is absolute, coupled with a closed interval. That means that these inequality signs are underlined, indicating I'm including -4 and 12 in my analysis. When you see those two items together, what that means to you is that you're going to do a candidates test on this problem. And to find my candidates, I need to find critical points and endpoints. If I look up at this graph, I can see my critical points are actually, I have 1 at -2, 2, 6, and 10. However, I know some of these critical points cannot be maxes and mins, because to be a max or min, I know I need a sign change in the g prime graph. And I don't see the sign change at 2, nor do I see it at 10. So I can actually weed them out of being candidates. I'm going to choose -2 and 6 to be candidates because it's where g prime equals 0 and undergoes a sign change, either positive to negative or negative to positive. So those are my critical points that I'm going to analyze. And also I know my endpoints belong in my candidates test as well, and they are the -4 and the 12. So here's my short list of possibilities to be absolute min and absolute max. What's going to determine which of these is the absolute is its value on the graph of g. So if I'm looking for max and min on g, then I need to find g of each of these values. So I'm going to take each of these x values one at a time and plug it into my function g. The x is the upper limit, so that's where I'm going to put the x value. So to find g of -2, I just replace the upper limit with a -2. When I do that, I saw my limits were reversed, so I just went ahead and put them in the correct order, and that's why this negative is out in front. And from there, I just take an area approach. The area from -2 to 2 is 8, but because of this negative that occurred because of the reversal of limits, it's actually -8. I go through each of these x values. I find g of 6, g of -4, and g of 12. And these are the values I'm looking at to determine my absolute minimum and maximum. I can see my minimum value here is this -8, and my maximum value is an 8. Also, it's important to realize, because these questions are asking for absolute minimum value and maximum value, what's actually answering this question is the -8 and the 8. So make sure you include that part in your explanation. To say that it occurs at x equals -2 and x equals 6 is optional. That part's not required. So point-wise, what you're going to earn is a point to select these critical points, and make sure you put why you're picking them. And it also indicates why you're not picking the 2 and the 10, because I'm only picking the places where G prime changes sign. You get a point to consider the endpoints, and by considering them just means you are somehow have them in that short list. It could be in that table of values, or you could just be showing that you're finding the values here. And 2 points are for the rest of it, which is the justification. So you want to make sure that you somehow show that you were considering these candidates. It doesn't have to officially show up in a table. If all you have is this part here that shows your candidates that you're considering along with their values, that would be fine. And then your final answer. In part D, I'm asked where g of x is less than or equal to 0. I first replace the g of x with its integral, which is the integral from 2 to x f of t dt. If I want to know where this is less than 0, I'm going to take an area approach. My integral is starting at the 2. So let's go up to our graph, and we're going to start our integral at 2. I'm going to pay attention to the area. So as I start changing this upper limit from a 2 to a 4 to a 6, what I can see at this point is because this area is completely above the x-axis, it is positive. And recall that I'm looking for where that area is negative. So I'm just going to keep it going. As I keep going, now I'm getting some negative area that's taken away from that positive area. I hit a balance right there, so starting at 10 is where this integral is going to equal 0. Because the remaining part of this is below the x-axis, we're also negative here. So I just found a negative interval that begins at 10 and goes all the way to 12. As I move to the left of 2, my upper limit is less than 2, so that means I have to switch them around. So I went ahead and switched the limits around and put x as the lower limit because I know it's going to be less than 2, and that put a negative in front. So I want to know where this integral is less than 0. If you want to handle that negative by dividing both sides of this inequality by it, what that's going to do is flip that inequality sign around. So you could look at it as the negative integral from x to 2 is less than 0, or you can look at it as the positive integral from x to 2 is greater than 0. As I start looking at these areas and playing with that lower limit, I can see that in this whole region, I have a positive area. So let's take on this interpretation right here. It doesn't matter what that lower limit is, anywhere from -2 to 2. If I put it as that lower limit, I'm going to have a region that is strictly above the x-axis, meaning it will be a positive area. As I adjust my lower limit to be even less than -2, I can see that it's given me some negative area here, but it's not enough to cancel out all that positive area. So my integral is going to stay to be a positive value. So any x value between -4 and 2 inclusively that I substitute in here for this lower limit will generate a positive area for me. So that is my second interval. So you get a point for this interval. They must be encased in brackets because we're including those endpoints. And the second interval is from -2 to 2.